Here's a water vapor map at the global level. What I just did there was this yellow line. That's where Indianapolis is located. And the green line, the equator. The two lines are the tropic lines, and then our Arctic Circle at the top and Antarctic Circle at the bottom. So this is just showing water vapors, not really trying to show land masses, but we can see them. South America, Central America, North America, we're somewhere right about there. Over here is our good friend Asia and Africa and Europe over there. So what we're going to try to do is we're going to try to see the equatorial low pressure trough. Do we see convergence? And this is using, in this case, just a looping video of water vapor. So let's try to do that. So what I did here is let's just zoom in and focus just on the tropics. Do we see, in this case, not so much convergence, we'll worry about that later. Do we see a pattern of east to west movement? Because that's one of the characteristics of the equatorial low pressure trough is the fact we have this east to west movement. And I think for the most part we do. So I'm trying to just visualize here. Do we see the equatorial low pressure? Do we see that east to west movement? And I think for the most part, I think we do. Very clearly over here, we're going to talk about Asia. Asia is kind of complicated, how it kind of messes up traditional global belt, global weather patterns and these climate characteristics. They got something called the monsoon, which I'll talk about later when we talk about climate. But this does, I think, a good job of showcasing that east to west movement. But also, in a certain extent, we also see, keep in mind, June to August, this is summertime, we do see convergence. We do see the winds kind of coming from the southeast in this particular pattern, and then we see winds coming from the northeast, converging here along just north of the equator here, just north of this green particular line.